Parts A and B in this question lead us up to the finale of part C, which we'll talk about in a minute. First thing, considering their difference or otherwise, find all possibilities for the common factors of n and n plus 3. So let's do what they've said. N plus 3 minus n is equal to 3. So they differ by 3. Now, if they differ by 3, there's no way that 4 could go into both of them, for example. They can't be at both in the 4 times table. And essentially, if a number goes into n and n plus 3, it must go into the difference. Therefore, common factors of n and n plus 3 are 1 and 3. Part B, we're told that n is greater or equal to 2 and Pn denotes the largest prime factor of n. If a and b are positive integers greater than 1, explain why P, AB must be equal to at least 1 of PA or PB. So for this, I decided to let A equal the largest prime factor that goes into A times some integer k. And B is the largest prime factor that goes into B times some other integer. Then AB will equal P A P B times Km. And it's clear, like there's no extra prime factors coming from this. So it's clear the largest prime factor is clearly PA, PB, or it could be that they're equal. PA equals PB. Therefore, PAB equals one of these. Now, the official answers do it slightly differently, so I'm pretty confident my argument is fine, but here's how they do it. They say let P equal PAB. This means that P divides AB. Since P is prime, it must divide at least one of A and B. Suppose P divides A. If A had a prime factor larger than P, that factor would also divide AB, so P would not be the largest prime factor. Therefore, P is the largest prime factor of A, which means that P is equal to PA. So just a bit of a proof argument made. I think both of these answers are okay. Right, let's bear those two things in mind and take a look at the last part. Find all positive integers such that P of this is equal to P of this. Well, the thing that jumps out at me is, we looked at two things multiplied together. So let's try and factorize the brackets, and they will indeed factorize really quickly. Oops. This is going to be n plus 2, n plus 7. Now this is simply going to be P n plus 1, because n plus 1 squared and n plus 1 will have the same largest prime factor. It's just in the second one I've squared it. Now, let's look at the different cases. We either had the largest prime factor of PAB was PA or PB, or that they were the same. Now, what if they're the same? Then you can't also, so we'd have to have that if Pn plus 2 equals Pn plus 7, then actually the highest common factor they can have is 5. Then it would be 5. But this won't go into n plus 1. If 5 goes into n plus 2, there's no way it's going to go into n plus 1. So I'm just getting that one out of the way. If Pn plus 2 is greater than Pn plus 7, then, like we said before, this thing is just going to become P of n plus 2. Okay, but these are one, this is just one more than this one. So the highest common factor here is 1. So there are no solutions. This just leaves us with the other one. If Pn plus 7 is greater than Pn plus 2, then Pn plus 1 equals Pn plus 7. Now, common factors of n plus 1 and n plus 7. Just trying to remember how it's phrased. Possible common factors, I should say, because it's not guaranteed for every single n. Are 1, 2, 3, and 6. Now, this one's not prime, and nor is this one. And we also need Pn plus 7 to be greater than Pn plus 2. So consider Pn plus 1 equaling Pn plus 7 equaling 3. And then Pn plus 2, which was smaller, is going to have to equal 2. That is the absolutely crucial bit of this question. And I just want to dwell on it a little bit longer. So I just want to kind of go here. So we've looked at these two scenarios where they were equal. If PA was equal to PB as such here, then we had 5, but then it didn't work here. So we rejected that. If Pn plus 2 is greater than Pn plus 7, then actually there's only that's not possible because the highest common factor of Pn plus 1 and Pn plus 2 is always going to be 1. We looked at this third case when Pn plus 7 is greater than Pn plus 2. Remember, we're using this argument from part B. Okay, the largest prime factor is going to be this, this, or this, and we've just looked at two cases. We're looking at a third one now. Then, if that is the case, then they're equal, but the only possible common factors are 1, 2, 3, and 6. These two are not prime, so the highest possible prime factor, if they're like that goes into both, because they have to go into both, has to be 3, because we said that this one was bigger than that one, so that is going to be left with 2. And this means actually, if their highest prime factor is 3, they must be powers of 3. So let's write a few down. By the way, they differ by 6. So that kind of gives it away. So we're going to get 3, 9, 27. Look, you can see the only one that differs by 6 is these two. So n plus 1 is going to equal 3. N plus 7 is going to be 3 squared, or 9. And therefore n is going to equal 2. We also see that n plus 2 is going to equal 4, which is just a power of 2. I should just add that differ by 6. So I just want to explain this bit again. I hope you're with me still. So we've considered this scenario, which I've explained. So n plus 1 and n plus 7, they must be multiples of 3 because their highest prime factor is 3. And I should add they can't have 2 as a prime factor because we know that Pn plus 2 is 2. So we know that 2 must go into this one. So 2 can't also go into that one. Did I say that? No, but I've explained it now. So yeah, they're going to have to be multiple powers of 3. This one must be some sort of power of 2. And then these two are going to differ by 6. So if I write down my powers of 3, I get 3 and 9. N is 2. I get n plus 2 is 4. This is my only solution. And let's just check. So P of n squared plus 2n plus 1 will equal P of 4 plus 4 plus 1, 9. And that's just 3. And then P of n squared, and I've forgotten what it was, 9n plus 14 will equal P. We're going to get 4 plus 36, 40. Sorry, I'm putting in n is 2, so let me take this step by step. 4 plus 18 plus 14, that's going to be 36. And 2 and 3 go into this. The 2 coming from the n plus 2, remember, and the 3 coming from the other one. And so the highest power is going to be 3. So it checks out. Right, that is a tough question, I think, but well done for sticking with it.